So in this video, we're going to talk a little bit about branching and keywords. So let's say I want to have a Boolean value. So I'm going to define something up here. We're going to call it a toggle. We're going to name it _lit. Say lit material. Define this as a float. Say it's defaulted to true. Then down in our command buffer, we'll get a bool, which will be _lit. And then now down in our fragment shader, we can change some stuff up here, and we can define n.l to be 1, n.v to be 1. And then instead of having these here, what we'll do is we will define if lit then we'll tell it to apply the lighting. Otherwise, it's just 1. Now, if I save this and we go over to our scene view here, we now have a toggle here called lit material. And as I change it, you can see it's either applying the lighting or not. So, while that is one way of doing it, it's not the best way of doing it. Because what this is doing is, since we're running it in the frag shader as an if statement, we're telling the GPU for every single fragment or every pixel that's visible on the screen, check if this is true. And if this is going to be used for a lot of shaders or you have a lot of checks, you're going to be wasting billions of clock cycles on your GPU checking these shaders. Now, for something like this, since we define it as a property and it's either true or false, it can't be both at the same time in one material, we can use a keyword instead. A keyword is a type of preprocessor directive. So the hash here is a special character indicating a preprocessor directive. So if I pragma a shader feature and we call this _lit on, we've told it that, hey, there's a feature here called lit, and we want to have a version of it that's either on or off. And what it's going to do is it's going to change how it compiles this shader depending on whether or not this value is on or off. So now up here, instead of being just lit in lowercase, we're going to be full uppercase. We need to change this to an integer. Set that to 1, and we'll change this to a toggle. Let's set that to 0 actually, because it'll default to 0 with the toggle. So we have that set up there. Then now down here in our shader, instead of having this if lit here to run each pixel, we'll do hash if _lit on. And then below we have to do a hash end if. So what this is doing is this is telling the shader to compile a version with this code and a version without this code. So if there is the code, it compiles a shader that looks like this. If there's not, if this value is off, it compiles a shader that looks like that. So it saves us from having that dynamic branching where it's checking that lit value every single pixel, every frame. So now if we go back here and we click this value, now that it's off, we have this. And what it did is it actually compiled a different version of the shader. So we have basically when we switch this, it's running two different shaders on this object. It chooses whichever one applies to the proper feature. So this saves us the dynamic branching, and you can check, sorry, no, not preferences. We go project settings, and then we go to graphics here. We can see there are 25 total shaders, 33 total variants. So a lot of these are by default just Unity ones that need to be included, the shaders for running lighting, the shaders for the terrain that's in the scene, the shader for the skybox. But there are 33 total variants. A variant means that there is a keyword with and without it in it, so it needs to compile both of those shaders. Something you do want to be careful of is when you're using a keyword, you can end up with a lot of variance, because with keywords, you're basically telling it, hey, I need one with every possible combination of these. So if I have one keyword, it'll create 2 variants. If I have 2 keywords, it'll create 4 variants, 3, 8, and so on. You get exponential increases, and this can mean that when you're building a shader, it might need to compile thousands or millions of variants. So you do need to be careful when using this. There are ways to prevent that massive bloating by having all these different versions. And what I'm going to do is I'm going to show you there are 2 major things here. So there's shader feature, which is basically a way of telling Unity, hey, we need to compile different versions of this, but when you build the project, only include variants that have this feature active in the build. Whether or not it's in a prefab or anything that way, that doesn't matter. Unity knows to look for that. But it says like, hey, if I have lit on all of these materials, it'll always compile the lit on. It'll never include the lit off version of the shader in the final build. If for some reason you need to change some of these features at runtime, because you can change this value at runtime if you want to, then instead of using shader feature, you would use pragma multi-compile. And this would say, no matter what happens, always include both versions of this keyword in the build. So that's basically, the shader feature is a way of cutting down when you have a bunch of shaders and they're not changing. If the shader itself is static and you're not going to be changing a lot of the keywords, but you make an Uber shader, use shader feature, because it makes it a lot easier to cut out what isn't needed when Unity does the final build. But use multi-compile if you're going to change it at runtime, because if you build and then at runtime you change a shader feature and the build for the other one doesn't occur, it can either just crash the game because that shader doesn't exist. It won't actually crash it. It'll just make everything look pink. Or it'll have to build it and it'll cause significant frame dropping as the GPU builds, because instead of actually rendering the scene, it's going to be busy building the new shader. So use multi-compile if you're going to change at runtime, shader feature if you're not. Now, there is something else with shader features that you can do. So what you can do is you can tell it, this is a shader feature, and by default, shader feature like this is telling it, okay, this is the entire shader. It's not per material. So we're defining it for the whole shader. Because I have this defined as a property up here and I'm setting it in the inspector, it overrides this to be local per material. If I didn't have this here and I was instead setting it from script, it would be setting it for the entire shader. So if you want to make sure it only applies to the local material, you would do shader feature underscore local. And that makes sure that this only applies to the specific material instance we're looking at. You can also do shader feature underscore fragment. And what this does is it tells it this shader feature only applies to the fragment. So when it's building the code and it's telling it the preprocessor directive tells it to build different versions of it, it'll say, okay, everything in the vertex and the geometry shader, that will be built the same no matter what. So this reduces build time because it'll build the shader with these being identical. The only part it'll try to change is the fragment. So you can use the fragment and vertex keywords. I don't believe there's a shader feature underscore geometry keyword. So just keep that in mind. And then if you're doing anything outside of your vertex or fragment, it needs to just be a shader feature. So for some things, like you might have different attributes or varyings that include, like if you're getting a shadow coordinate, you would need to have a preprocessor directive and say your varyings that was a float 4 of the shadow coordinate. That would just be something you define there, because whether or not you have shadows active will affect whether or not you need that value. So by using a preprocessor directive rather than just defining it always, it clears up a little bit of your VRAM. So instead of having a float for defined always for the shadow coordinate, you can say, okay, only if rendering shadows is active do you allocate the memory for that float for. So you can use them anywhere inside the HLSL program block. You cannot use it outside. So you cannot use it above the HLSL program in the pass. You can't use it in the properties. Those are outside of it. This is a preprocessor directive for HLSL only. So that's the basics of a shader feature. I'm also just quickly going to go and open up the URP lit material just to show you how Unity uses some of the shader features. So if I open this up quickly, takes a few seconds. So this is the default URP lit material. So if I go here to forward lit, which is the standard forward rendering mode, you can see here there are a lot of different keywords. So there are a bunch of shader feature local fragments. There are some multi-compiles. There are lots of different keywords that occur in here. And the reason I'm showing this is, one, to show that in order to get performance, if you have a lot of different options in your material, you will need to use this multi-compile, because it bloats the material significantly if you don't, and it seriously reduces your performance on your GPU. But the other reason I'm showing this is to show you that Unity has a bunch of these already defined. So if you're doing something that relies on having, say, a normal map defined, you'll still need to define this in your shader, that this is a feature and that it's linked to a property called, bump map in this case, which I'll show how the custom editor influences that later. But you can pull some of these Unity shader features, especially for something like lighting, figuring out the different light modes, quality. You can pull that directly from Unity if you need to, and it will compile properly. The other issue is that Unity has a hard limit of 256 keywords. In the default rendering of the URP, there are, I believe, 62 keywords. Let's say about 60. So you have 256, but Unity already uses 60 of them. So you actually have about 190 available for you to use. So that's something to just be aware of. While these shader features are useful, one, it means it will have to compile thousands to millions of them, so it means your build will take a long time. But two, you can't have more than the allowed amount for Unity. You can't exceed 256 in total, so these are great, perfect for performance, but don't overuse them. In the next video, we're going to look at actually doing some PBR rendering and trying to recreate what happens in the lit shader here in our custom Uber shader.